Okay, we're going to finish this up, especially since our class Connect today was talking about the elimination method for solving systems of equations. I just realized we actually never really wrote up here. Systems of equations. There we go. Okay, so let's see. We did that in orange, we did that in green. I think we should do this in purple. So just to find my purple pen, here we go. Okay, so step one for the elimination method. Bringing the camera down while it falls apart. Sorry about that, folks. Bring this a little bit closer so you can see better what I'm writing. So step one is to rewrite the equation if you need to. Let's see if I can bring this a little bit closer. There we go. Rewrite the equations if necessary so that when they're added together or combined, one of the variable terms will be eliminated. And then the remaining variable can be solved for. So let's look at an example here. Let's see. How about we've got 2x plus 4y equals 10 and negative 4x plus 2y equals negative 30. Okay, so we don't see any variables here that are just going to drop out when we add these equations together. So we could do a couple of things. Either way, I should say, we're going to need to multiply by 2. So we're going to either multiply this top equation by 2 or this bottom equation by 2. And the reason why is because we want the coefficients of the variables to be opposites. So like here we have a negative 4x. We would love for this to be a 4x. And like this is a positive 2y, well, we would love for this to be a minus 2y. So those would drop out. We can't have both ways, but what I'm going to suggest actually is to multiply both sides of this top equation by 2, because I want the positive 4x. So that the x's will drop away. So I will rewrite that equation as 4x plus 8y equals 20. And then I'll write the other equation right next below it. We like to keep everything together so we don't lose anything. Okay, so that was step one. Is try and get opposites. Okay, and just as a reminder, we're using the multiplication Yeah, this is why I don't think we're going to do it on both sides anymore. Property of equality. Okay, excellent. On to step 2. Now, here I'm going to say add the equations together. So I'm going to use my new equations here. So I'm going to use my 4x plus 8y equals 20. And this is just like comparing like terms, except we're doing it with equations. So negative 4x plus 2y minus 30. I'm going to add them together. 4x minus 4x, that becomes 0. I love when we can cross things out. Doesn't really mean that we're canceling them, but they just become like they don't matter anymore. So now we've got, whoops, I forgot my equal sign here. 8y plus 2y, we've got 10y equals 20 minus 30, or 20 plus negative 30. It's going to be negative 10. Okay. Now, the part that the step doesn't say, it says add the equations together and then solve for the remaining variable. Here. Add, then solve for remaining variable. Crunch. Okay, cool. So to do that, I now need to divide by 10, and I get that y equals negative 1. Okay. So now I'm going to substitute I always do that when I have to write that word, the value of negative 1, or I should say y equals negative 1, into the original equation, the one we changed. So that's going to be this one over here. Okay. And then we're going to solve for the other variable. So we're going to take our original equation, 2x plus 4y equals 10. But now we know that y equals negative 1. So we can substitute it right into here instead. Instead of multiplying by y, we're going to multiply by negative 1. So it's 2x plus 4 times negative 1 is going to equal 10. Let's simplify that a little. 2x minus 4 equals 10. And now we're going to add 4 to both sides. Just like unraveling a skein of yarn. Get 2x equals 14, so x equals 7. So we have a solution. Our solution, I'm going to write it right up here. Our x, we want to say, is 7. And our y is negative 1. Okay? So our solution to a system of equations is always an ordered pair. So we always want to write it like that. Okay? And then, of course, we need to check our solution in both equations. So I'm going to start with the first one. We said 2, and we said that x was 7. 2 times 7 plus 4 times negative 1. That should equal 10. That's what we're hoping. Let's see. 2 times 7 is 14, plus 4 times negative 1 is negative 4. Well, adding a negative is the same thing as subtracting. So 14 plus negative 4 is 10. 10 equals 10, so it definitely checks in the first equation. Good on us. And our second equation, negative 4 times 7, because that's x, plus 2 times negative 1. That should equal negative 30. Okay. Negative 28, because that's negative 4 times 7, plus 2 times negative 1 is negative 2. Should equal negative 30. So if we're 28 down on the negative side, and we go further down on the negative side, we're going to get to negative 30 equals negative 30. And it checks. So we are all good. We're golden. These are our 3 ways of solving systems of equations. And there you have it. So I hope this is helpful for you, and I will talk to you soon.